I'm Kevin Simmons, CEO of Blue Cube Aerospace.
And together, we formed the Aerospace and Innovation Academy, which we'll talk with you about today, about how the model of the future can be a disruptive educational system.
First of all, we want to share with you the concept of blue sky learning. Blue sky learning is really a combination of tenets from the grit philosophy and the growth mindset sort of mentality, where there aren't limitations on a student as far as what they're able to learn or what they're able to accomplish. With our teams, our small teams, we set and achieve very ridiculous and extraordinary goals. We do this by setting up a series of milestones that are achievable and help to guide and mentor the students. We believe that this is an effective way to develop human capital and increase the number of students in the STEM pipeline in the United States. We also believe that our methods will help to reduce the number of students that leak out of that STEM pipeline. So our aim is to inspire the next generation of the U.S. STEM workforce, and one of the things that you'll learn about in our presentation today is that we really rely heavily on trying to help the students see that they can become the people that they're interacting with. So for instance, engineers, scientists, etc.
And that's precisely why we need a new educational model. Education in the United States was originally created to democratize their citizens. They were essentially looking to create students who would be able to give back to the workforce. But we can see that this is not happening, and it hasn't been happening for some time. Students are still being kind of exposed to that educational model of the teacher in front of the classroom and learning just from books, are not actually getting those 21st century skills that so many of those STEM careers are actually looking for. Post-COVID, this is the perfect time to actually embrace a newer model of education. Schools that now have access to technology in ways that they did not before are encouraged to be able to recognize that the work that we do as students with teams, where they are connecting with industry in order to actually see themselves as those engineers, this is the way that we can go about doing that. And it will create the school of the future for those who are willing to just zoom in and be part. And a lot of this is based on the idea of social cognitive career theory. As Kevin mentioned earlier, essentially a student who doesn't identify him or herself in a particular field is unlikely not only to enter that field, but is more likely to leave that as they go on. We start with students as early as kindergarten with the idea of helping them to recognize that they can be engineers, they can be scientists. And it's especially important if they don't have this access at home, not only just for all students, but even more so for underrepresented populations, such as people of color, women, and particularly women of color. So by starting early with students, and oftentimes, we think that it's only the university students who can do these kinds of activities. That key is starting earlier so that they can imagine themselves in those career of the futures. And project-based learning is the perfect way to do that in this new blended model of online and face-to-face learning. We'll talk to you today about some of the ways that the Aerospace and Innovation Academy will be implementing that project-based learning. And so essentially the way we started, I met Kevin about 7 years ago when he came to the school where I was at. And he was working with a group of students to build something called a cube satellite. And I didn't know what that was at all. I was just the debate teacher, and my students that we shared were oftentimes talking about these satellites that they were creating. And in fact, before long, they were being asked to go speak at places like City Hall and even to our state capitol. And so I kind of got involved with the group so that the students were able not only to have content knowledge, but we're also able to communicate it articulately. And that's kind of where we formed the idea of the techies and the talkies, where he's kind of training them in their content area, and I'm helping them to be able to speak about that. From there, the students realized, none of my friends at our local schools are doing anything like building CubeSats or launching high-altitude balloons or talking about lunar rovers. So how do we change that? And so we started working with our congressman in order to create some legislation. The idea of that real hands-on application here is not only seen with building spacecraft, but also with legislation. And so with his help, the students created a resolution that helped to recognize the CubeSat launch initiative. And then it was followed up with the idea of recognizing CubeSats as a disruptive educational model. So by employing that knowledge, seeing how real-world advocacy works, our students definitely get an idea of they can imagine being that politician themselves or being a congressperson in addition to being an engineer.
So you've heard about CubeSats, but let's take a little deeper look at what exactly they are. A CubeSat is a picosatellite form factor that was originally designed by two university professors to help educate the university students in the 4 years that they had them. In this case, the students would design, build, test, and fly a small satellite while they were in school. Now, this form factor is simply a definition, if you will, of the size, volume, and mass constraints for the CubeSat. 10 centimeters on a side, not to exceed 1.33 kilograms, and a volume of 1 liter. This disruptive form factor, because it lowered the cost and the access to space, it actually helped to democratize space where many nations could now launch their first satellite. But more importantly, because of the lower costs, it enabled not only universities and their students to launch spacecraft, but also some high schools and even one middle school. And we are the middle school. Our satellite team was the first selected by NASA's CubeSat launch initiative in 2017, and we did fly in December of 2018. Our first mission was a biological payload. We flew an extremophile bacteria to look at its viability in low Earth orbit. Now, as you would imagine, the excitement of this mission was extreme, and the excitement led to students wanting to design and build and fly more satellites, which led to our second selection, an idea which was originated by a seventh grader. And this satellite, the CapSat-1, will evaluate a novel power system based on capacitors. This CubeSat is scheduled to fly to the International Space Station in December of 2021 and be deployed shortly thereafter.
So that kind of gives you a little bit of an overview about why we decided to create the Aerospace and Innovation Academy. But we want to just reinforce the idea that it is that time for that new educational model, because building CubeSats is one thing, being able to talk about what you're learning is another. So we want to be able to blend that idea of working with industry as well as the students in the classroom so that their curriculum is beyond those four walls. When we talk about entrepreneurship as one of those legs, it's really important for the students to be able to see themselves as teams. When they're doing these project-based learning activities, oftentimes it requires them to not be individual, but rather to work within larger groups. And so it's especially important that as the students kind of come together, they solve many problems. And you can see in the top left here, this is a group of students who were not only working with their American counterparts, but once we placed first in the United States for a space settlement competition, we traveled to Beijing, China, where the students were then broken into teams as though they were the space companies of the future to be selected. By working together, it allows the students to realize those real world scenarios as well. But in addition to competitions and the idea of presenting as teams, students are also presenting at conferences. So like we're presenting to you today, you'll likely see some of our students presenting at this same conference as well. Ideally, the Aerospace and Innovation Academy, in order to build that pipeline, would create those internships and the apprenticeships that allow those students who are already doing the work of industry to kind of just head right into that after they graduate. As you can see from our current projects, there is a lot already going on. We launched in January, essentially, with an online program that kind of built off of the program that Kevin had already begun with those CubeSats. So students are still turning in proposals, we're still writing papers for conferences, and we still have different teams who are meeting in order to design the other spacecraft that they're interested in building. But as far as the future is concerned, we look forward to taking this model and being able to expand it even further, not only to after-school programs, but to schools that are able to draw a curriculum that connects all parts of an aerospace curriculum to the industry outside. We look forward to partnering with other schools in order to replicate this model. So if you would like to join us or reach out and find out a little bit more about Cube satellites, our emails are here on the screen. You certainly are welcome to contact us, and then our social media is over to the left. Thanks so much.